This genuine Unreal Engine 5.5 run tracks one query agent inside a field of 196 moving agents. The first frame shows the raw positions. The second reveals the spatial grid. The third highlights every candidate stored in the surrounding cells. The fourth filters those candidates to exact radius neighbors and draws the verified connections in green. In this lesson, we will convert world positions to integer cell keys, build a TMap of buckets, search only the cells that can overlap the query radius, apply an exact distance check, compare every result with brute force, visualize the query stages with instanced meshes, and measure the candidate reduction in a native Unreal runtime. The cell key uses floor of world X divided by cell size and floor of world Z divided by cell size. This demonstration treats X and Z as the simulation plane and uses cells 180 Unreal units wide. The result is an FIntPoint suitable as a TMap key. Floor is important for negative coordinates. Truncating -0.01 to 0 would incorrectly place a position just left of the origin in the positive cell. The automation test explicitly verifies that -1 on X and Z maps to cell -1, -1. At the start of each simulation step, reset the bucket map. For every position, calculate its cell key and call find or add to obtain that bucket, then append the agent index. Building the grid is linear in the number of agents, aside from hash map costs. Indices keep the buckets small and let the query return to authoritative position data. In a real game, rebuild only for moving populations that need it, reuse allocated storage, and profile whether a dense array, sparse hash, or engine-level system best matches the world. Calculate the query agent's center cell. Cell range is ceiling of radius divided by cell size. Here, 160 divided by 180 rounds up to 1, so nested loops visit offsets -1 through +1 on both axes, a 3x3 neighborhood. Every index in those 9 buckets becomes a candidate, except the query agent itself. The orange panels and agents in the genuine capture show this broad phase. They are possible neighbors, not confirmed neighbors, because a square set of cells extends beyond the circular query radius. For each candidate, compare squared distance from the query position with squared query radius. Squared distance avoids a square root and keeps an index only when it is truly inside the circle. Sort the result when deterministic order matters for tests or downstream logic. In the verified frame, orange points remain broad-phase candidates, green points are confirmed neighbors, and green lines connect them to the red query agent. The grid is an acceleration structure. It must not change which neighbors the gameplay rule accepts. The brute force reference checks the tracked query against every other agent, 195 comparisons. The final captured query examined 38 grid candidates and accepted 17 exact neighbors. Across 838 moving queries, the grid performed 46,884 candidate checks instead of 163,410 brute checks, a 71.31% reduction. Every grid neighbor array was compared with brute force, and mismatch count stayed 0. This is a measured result for this density, cell size, radius, and query stream, not a universal performance promise. These are 4 genuine game mode frames from one compiled Unreal execution. Ready shows all 196 agents and the red tracked query. Grid built reveals the active spatial partition. Candidates highlights the 9 overlapping cells and their orange bucket contents. Verified recolors exact neighbors green and draws their connections while leaving rejected candidates orange. The moving positions, occupied cell count, candidate and neighbor counts, reduction metric, query trail, grid geometry, highlights, and connection lines all come from the included C++ project, not generated stand-ins. The Unreal automation test passed with 1 success and 0 warnings or failures. It checks negative coordinate flooring, the positive cell edge, a known 4-point query, and every query in a deterministic 49-point grid against brute force. It also verifies the configured cell size and query radius. The real runtime completed 838 grid builds and queries over 196 moving agents, recorded more than 15,000 accepted neighbor matches, produced all 4 native captures, kept mismatch count at 0, reduced candidate checks by 71.31%, and reported valid true. The reusable pattern has 5 parts. Hash each position into an integer cell. Bucket lightweight indices. Query only cells that overlap the search radius. Filter candidates with the exact gameplay condition. During development, verify results against a simple brute force reference. Spatial hashing helps flocking, local avoidance, damage queries, item pickups, particles, and proximity systems, but it is not automatically faster at every scale. Cell size, density, rebuild frequency, memory allocation, threading, and cache behavior matter. For AI-assisted Unreal development, the key advantage is testability. Optimization is accepted only when output equivalence and a real workload reduction are both visible.